All right, finally, ladies and gentlemen, what I would like to do after we've talked a little bit about triangles and how to find missing angles is let's talk about how to classify triangles. So just some words, some vocab. All you have to do is match up and name what type of triangle it is, and then there's a special relationship we'll talk about at the end between the sides and the angles of a triangle. So um, something this is important. I don't know if you want to screenshot it, pause it to do your problems, but the first three you're going to do are this. You're just going to classify the triangles based on their sides and based on their angles. Okay. In terms of sides, the first one you're never going to see, at least on this worksheet, you won't see it. I'm not going to say you're never going to see it, but equilateral is how you say that, and it means all three sides are the same length. Like I said, you're not going to have to worry about that, but these two you will. Isosceles means that two sides are the same, are congruent. That's what congruent means. They are the same. So if you have a triangle and two sides are the same, it's isosceles. And then if none of the sides are the same, it has all different sides. It's, all of the sides are kind of wonky. It's got the funny word, scalene. All right. Now, in terms of the angles on the inside, if all of the angles are, now these words should look familiar to you. Acute means less than 90 degrees. So that means all three of the angles are less than 90 degrees. Obtuse means one of the angles is greater than 90. It's not possible for two of them to be more than 90, because it would no longer be a triangle. And then a right triangle is you have a right angle. Now you can use both of these to classify triangles. All you have to do is do this. Let's match it up. All right, let's do it in terms of sides. How many sides do we have that are the same? None of the sides are the same. That is scalene. You'll see this most often, I think. All right, so this is a scalene, and then let's look at the angles, 22, 68, and 90. 90 means it's a right triangle. So it is a right scalene triangle. All you have to do is type that in right here. Oops, what in the world? There we go. Right scalene triangle. All right, let's take a look at the next one. Let's look at the sides. Are any of the sides the same? Actually, yes, they are. We have two sides that are the same. Ooh. So this is an isosceles based on the sides. Two sides are the same. And in terms of the angles, 32, 32, and 116. That means that this is obtuse. So it is an obtuse isosceles triangle. You just got to look at the sides, decide what's happening there, and then look at the angles. So obtuse, one of them is bigger than 90 degrees, and it is isosceles. All right, third one. So let's look at the sides. We have two sides that are the same, again, so it is isosceles. So in terms of the sides, it's isosceles, two sides that are the same. And then angles, 51, 78, 51. They're all less than 90, so it is acute. All of the angles, all three are less than 90. It is acute isosceles. Right. Okay. So finally, the last thing you're going to have to take a look at is this. It says, what is the longest side? What is the shortest side? This is kind of cool. And you can take notice of this in all of the other examples that we did. The longest, so if you look, what are we given? We're given nothing but the angles. So what the heck does that have to do with the sides? We don't know anything about the side lengths. Or do we? There are only three angles and three sides. And what's really cool is the biggest side is always across from the biggest angle. So our biggest angle is 62. So that means our biggest side is this side right here. And think about it, and an angle opens up. So if it opens up really big, that side is going to be really big. Whereas if it doesn't open up very much, that side is going to be really small. So our biggest side is across from our biggest angle. So when we look for the longest side, it is this side, and we name it by the points at the end of it. So this side is AC. So our longest side is AC. Okay, where is our shortest side? We'll find the smallest angle, 58, and across from it is our smallest side. BC is our smallest side. AC, our biggest side. And you can take notice of that in all of our previous examples. Check it out. What's the biggest side here? Look at it. Our biggest angle is 78. It's across from the biggest side, which is 9.7. 116 is across from our biggest side, which is 3.7. And our biggest side here is 14.4. So it's always the biggest side is across from the biggest angle, and the smallest side is across from the smallest angle. All right.